Good morning students, welcome to the series of the lecture. In my previous lecture, what you had to learn, that is the limit continuity, and these concepts are to be over. So in that we had to do so many problems on that is to be available so in our textbooks. So the continuation of this class is to be the differentiation. So in this session, the student has to learn the concept of the derivative in the calculus, who find the derivative, what is the meaning of the differential calculus, what does it mean to the differentiated function in the calculus, and the applications of the derivatives, where these derivatives we have to use. So that is the rate of change of the quantity and the tangent and normal of for a curve at a point, and increasing or the decreasing of a function, and the maxima and minima values of the given function, and the approximate values of the quantity, and the real life applications of the derivatives. These concepts the student has to be learned. So where the derivatives are to be used. So please see this. What is called first of all differential calculus is the derivative is the slope at a point on a line around the curve. It is the fundamental tool of the calculus. So please all of you observe this. So this is the coordinate plane. This is the coordinate plane. So in that this is the coordinate plane. In that what you have to consider. So this is the coordinate plane. So then, so in that coordinate plane, so this is the line only, this is the straight line only. So the derivative is nothing but of the slope of this line, that is to be denoted as m is equal to dy by dx. What is this dy by dx? Here we have to see, so the two variables x and y. Here y is called as the dependent variable and x is called as the independent variable. All of you catch your point. So where this dy by dx has to be used. For example, so if you are to ride on a bike, so whenever so you go to the speed of 40, so then along with the time, here the time is to be the dependent variable and the speed is to be the independent variable. Whenever the time is to be changes, automatically the distance traveled by you is also to be changed. So there are the two quantities you have to observe here. So in that dy by dx means that is called as a rate of change. That means here x is called as the independent variable and y is called as the dependent variable. The time will be changed automatically. The distance traveled by the student or the person has to be changed also. So here we have to evaluate by using of this derivative. All these quantities you have to find out. This one has to be the differentiation only. Okay. Now, so basically the derivatives are to be found by Isaac Newton. So in the year of 1642 to 1727, and also the Leibniz. These are the famous mathematician scientists. They are invented this differentiation concept. Now, so what is meant by the differentiation function in the calculus? That is what you have to observe here. So that is the rate of change. That means here delta y represents the change in y, and delta x represents change in x. Here what you have to observe here, so delta y by delta x is equal to f of x plus delta x minus, so f of x by delta x, f of x plus delta x minus f of x by f of x. This is our given function f of x. In that so there is a small change in x, we have to denote it as to be delta x, that is called as the delta x. Delta x is called as the smallest change in x. So here, whatever the example we had to consider in the previous, so that we have to take that example. Suppose in a particular time, the person has to be in a bike, on a bike, so he may be traveled after 1 minute, so that means certain the change is to be occurs here. So we have to consider the change as to be delta x, that is the change in x, Therefore, so how we have to evaluate rate of change? Delta y by delta x is equal to f of x plus delta x minus f of x by delta x. This is equal to, so f of x plus delta x minus f of x by delta x. This is called the rate of change. Wherever the value of x is to be changed along with the y also. So the change you have to consider as to be delta x only. So please all of you see this. So this can be treated as the rate of change. Delta y by delta x is equal to f of x plus delta x. This is delta y by delta x is equal to, so f of x plus delta x minus f of x by delta x. All of you catch your point. So where x belongs to open interval a comma b and f is a differentiable on open interval a comma b, this can be represented as by graphically. Okay, please all of you say this. There is a small change. This is the function f of x. This is the function f of x. Here I have to assume this is the coordinate plane. This is the coordinate plane. So actually the function is to be f of x, y is equal to f of x curve. So there is a small change. You have to consider this one as to be delta x, that is change in x, along with so this is along the x axis and this is along the y axis. Whatever the change occurs in the x axis, I have to treat it as to be so delta x only. Here whatever the change is to occurs in the y axis, I have to treat it as to be delta y. All of you catch your point. There is a slightly change, okay, in both x and y. Here whatever the variable we have to consider is to be, this is to be the dependent variable and this is to be the independent variable. So likewise you have to consider this. Now, so we have to see the actual definition of this differentiation is whatever the contents we have to discuss in the limits and continuity, along with the same we have to explain the definition of this differentiation also. So this is called as the derivative. So derivative, in that derivative that is so derivative, let f of x be a function which must be either the trigonometric function, logarithmic function, exponential, whatever the function you have to consider mathematical function. So for a given epsilon greater than 0, for a given epsilon, this value is to be so 0.000000 something value, that is to be negligible value. So which is to be greater than 0, there exists a positive integer. There exists a positive integer. So delta x is there exists a positive integer delta, that is also equal to so 0.000000 something one value, which is also to be greater than 0. Slightly, so that is a negligible value. Had to consider that one has to be greater than 0 only. So there exists a positive integer delta greater than 0 such that what we have to discuss in the limit and the continuity. So here the limit value is to be exist. So limit of delta x is tends to 0. So f of x plus delta x minus f of x by delta x. Limit of delta x tends to 0, f of x plus delta x minus f of x by delta x. If the limit value is to be exist only, then only the function f is said to be so f of x is said to be the variable at that particular point x only. Okay, so basically this is can be denoted by, that is dy by, or simply d of f of x by dx. Simply I have to write it as derivative of the function f of x with respect to x only. So basically that is to be denoted by f dash of x. That is to be represented as f dash of x means differentiation of the given function f of x with respect to the variable x only. That is the meaning of this one. Now, so with this principle, within this principle, how the derivative, the formulas are to be exist here. We have to see by using the first principle only how this one is to be getting. So, we have to see into that example. There is no problem at all. So, before going to that actual syllabus, so we have to know how these derivatives are to be useful. So, where in a real life applications, where the derivatives are to be useful for this. Please all of you see these applications of the derivatives to find the rate of change of the quantity. Rate of change of the quantity. So that already we have to take the example. A person has to be traveled in a certain distance in a certain time interval. So whenever the time is to be changes, then automatically the distance traveled by the body is also to be changes only. That is that we have to use by using of this derivative, so we can easily calculate that one. Okay, that is one real time application of this. Similarly, so to find the tangent and the normal curves. So for that purpose only have to use the derivatives also. Okay. Now, so here, so where the function f of x is to be changes, that is to be maximum value is to be reaches and the minimum value is to be reaches, by using the concept of the derivatives, we can easily identify where the function is to be the increasing or where the function is to be the decreasing. Likewise, so we have to identify by using of these derivatives only. This is also another important application of these derivatives. Now, so here, please all of you see this. So for this function, whatever the function you have to consider, so where the function has to be reach the maximum value and where the function has to be reach the minimum value. So likewise, this concept also we have to see by using of these derivatives only. Okay. So they are the real-time applications. An odometer, that means the speedometer, what you have to use in the bikes and the cars. So the odometer is also to be changes the distance traveled by that persons. So whenever the time is to be the changes, then this is the best example for the real-time applications of the derivatives. Similarly, so in the business, we can find the profit and loss by using the derivatives through the converting the data into the graph. So that is what we have to see in that our Sensex. Sensex is also to be so under the category of this derivatives only, that is to be applicable. So similarly in the physics, there is the Newton's second law of motion and the Newton's law of cooling, law of natural growth or decay. So these concepts are also to be applicable to the derivatives only. And also similarly the economics and also the geology, in that the derivative part is to be, so that is plays an important vital role in that remaining other subjects also, geology, physics, chemistry and economics, whatever it may be. So in that derivative concept is to be the very plays an important vital role in that areas only. Okay. Please all of you write down these formulas. So again I have to write here. So I think that is a small blood is to be occurs. That is again I have to write these formulas. The first formula is please all of you write down the formulas. First one. So d by dx of x power n is equal to n into x power n minus 1. How these formulas are to be occurs, we have to see by using the first principle only. So how these formulas, we have to see all those, some of the examples I have to done. So after completion of writing of these formulas, please all of you write down these formulas. Now the second one is derivative of, that is d by dx of, so the constant value is equal to 0. Constant means whatever, so in the problems that may be getting the constant values, the derivative of that function with respect to x, constant value is to be 0. Similarly, the third one is d by dx of e power ax, so that is equal to a into e power ax, where a is any real number, that is for all a belongs to the real number system R. Suppose in place of a have to take 1 only, e power x is equal to 1 into e power x. E power 2x means 2 into e power 2x. Similarly, e power 3x means 3 into e power 3x. Similarly, e power 4x, 4 into e power 4x. Likewise, so similarly we have to take the negative values also. E power minus x is minus 1 into e power minus x. Next one, e power minus 2x is minus 2 into e power minus 2x. E power minus 3x is minus 3 into e power minus 3x. Likewise, you have to practice the formulas. So that means then automatically you may be getting the derivatives and the integrations also. Please all of you be careful about that. this derivative concept, whatever the procedure we have to done here, the reverse process is equal to the integration part only. That is why, so you have to learn all these formulas from basic onwards. Okay. Now the fourth one is d by dx of a power x is equal to a power x into log a. Here also for all a belongs to capital R. Will you catch your point? So you have to practice these formulas as d by dx of 2 power x, that is equal to 2 power x into log 2. d by dx of 3 power x is equal to 3 power x into log 3. d by dx of 4 power x is equal to 4 power x into log 4. You have to practice these formulas in this way only. Then automatically you may be getting the derivative part is to be very easy. Okay. Similarly, the fifth one is d by dx of, so d by dx of log x to the base e, d by dx of log x to the base e is equal to, so 1 by x if the case of x must be is to be greater than 0. If the case of x must be greater than 0. Next, the sixth one is, so d by dx of log x, d by dx of log x to the base e is equal to, log x to the base e is equal to, this is 1 by x into log a to the base e. Please all of you make the difference between those two. So because whatever the base value in the logarithm have to put, that is e, then automatically this is to be the natural logarithm. So if the natural logarithm is to be occurs in the formulas, then the formula for the derivative is to be 1 by x. And d by dx of log x to the base e is equal to 1 by x into log a. So all these are the formulas for the exponential functions and the logarithmic functions only. Now we have to see so into the another trigonometric functions. So in the second unit, whatever the trigonometric ratios you have to learn, that is sine, cos, tan and cosecant, secant, cot. So how these are to be useful for the derivatives only. Okay. So this we have to say by using of this. Please all of you say this. Now the next formula is to be, so the trigonometric formulas, trigonometric ratios. What are the trigonometric ratios are there? So sine, cos, tan and cosecant, secant, cot, all these are called as the trigonometric ratios that already have to learn in the second unit of the trigonometric concept. Now, so how these are to be useful in the derivatives also. Okay. So what is the next formula? That is so that is seventh one trigonometric ratios, that is d by dx of, so sine ax is equal to, d by dx of sine ax is equal to a into cos ax. So we have to see with the proof how these formulas are to be getting. So after completion of this, so how these are to be getting by using the first principle, we have to see in that one. Okay, no, there is no problem at all. So how these formulas you can easily remember these formulas. Okay, please all of you see this. You have to practice likewise. So d by dx of sin x, that is equal to 1 into cos x. That means here what I did, in place of a I have to replace a by 1. Similarly 2, 3, 4, 5, 6 up to 10. Similarly minus of 10, likewise you have to practice these formulas. So d by dx of sin 1x is equal to 1 into cos 1x. d by dx of sin 2x is equal to 2 into cos 2x. d by dx of sin 3x is equal to 3 into cos 3x. d by dx of sin 4x is equal to 4 into cos 4x. d by dx of sin 5x is equal to, so 5 into cos 5x. Likewise you have to practice all these formulas only. Okay. Now the eighth one is so d by dx of cos ax is equal to minus of a into sin ax. So please all of you see this. Whenever the trigonometric ratios are to be started with the letter C, then automatically the derivative is to be the negative. Please likewise you have to remember all these formulas. Clarification point. here the cos function is to be started with the letter of C. So whatever the trigonometric ratios are to be started with the first letter is to be C, then only you can take the negative sign. Okay. So d by dx of cos ax is equal to minus of a into sin ax. How we have to remember these formulas? D by dx of cos x equal to minus 1 into sin x. D by dx of cos 2x equal to minus of 2 into sin 2x. D by dx of cos 3x is equal to minus of 3 into sin 3x. D by dx of cos 4x equal to minus of 4 into sin 4x. D by dx of cos 5x equal to minus of 5 into sin 5x. Likewise, you have to practice these formulas. Okay. Next, the ninth one is, so d by dx of tan ax is equal to, d by dx of tan ax is equal to, so a into secant square of ax, next one. So the 10th one is d by dx of, so that is cot ax is equal to minus of a into cosecant square x. D by dx of cot x is equal to minus of a into cosecant square x. Please all of you see this. Here in this trigonometric ratio, the letter is to be started with C. That is why in the formula that may be getting is to be negative. Now d by dx of cot x equal to minus of 1 into cosecant square x. So now d by dx of cot 2x is equal to minus of 2 into cosecant square 2x. D by dx of cot 3x is equal to minus of 3 into cosecant square 3x. D by dx of cot 4x is equal to minus of 4 into cosecant square 4x. Likewise, you have to practice these formulas. And the 11th one is d by dx of, so secant ax is equal to, d by dx of secant ax is equal to, so a into secant ax into tan ax, because this ax I have to written as the amplitude of the trigonometric ratios. Okay, d by dx of secant ax is equal to a into secant ax into tan ax. This is into, in between those two functions, into is there. Therefore, how I will practice, d by dx of secant x is equal to 1 into secant x into tan x. D by dx of secant 2x is equal to 2 into secant 2x into tan 2x. D by dx of secant 3x is equal to 3 into secant 3x into tan 3x. D by dx of secant 4x is equal to 4 into secant 4x into tan 4x. And d by dx of secant 5x is equal to 5 into secant 5x into tan 5x. Likewise, you have to practice all these formulas. And the 12th one is d by dx of, so cosecant ax is equal to, d by dx of cosecant ax is equal to minus of a into, so cosecant ax into minus of a into cosecant ax into cot ax. These are the formulas for the differentiation of all the trigonometric functions. Okay, again you have to remember these formulas. So here also the trigonometric ratio is to be started with the letter of C, then only, so the derivative of this function is to be negative. How we have to prepare this? D by dx of cosecant x is equal to minus of 1 into cosecant x into cot x. D by dx of cosecant 2x is equal to minus of 2 into cosecant 2x into cot 2x. D by dx of cosecant 3x is equal to minus of 3 into cosecant 3x into cot 3x. And d by dx of cosecant 4x is equal to minus of 4 into cosecant 4x into cot 4x. Likewise, you have to practice all these formulas. Okay. Now, so next one. So these two are the very important formulas, and this one also. So this is called as division rule and the sum and product rules. So that means here that we will be getting, so d by dx of, so f of x plus or minus of g of x is equal to, suppose in a function that having so the addition and the subtraction that having the different functions, then only the derivative is to be applicable to the remaining two functions also. That is equal to d by dx of f of x, d by dx of f of x plus or minus of d by dx of g of x. Clarification point. So plus or minus, whatever you have to take, this is plus, then automatically you have to treat it, this one has to be plus also. If it is minus, then also in the formula that may be put minus also. Okay. Now, so the another one is here d by dx of so c into f of x. C into f of x. This is called the linearity property. So in that function that having the constant is there in the multiplicity, so we have to bring that constant in front of the derivative. Okay. So c into d by dx of f of x. C into d by dx of f of x. All of you catch your point? Now, so now the next one is to be product rule. This is called as the product rule. So d by dx of so f of x into g of x is equal to d by dx of, this is called the product rule. So then how we have to derivative this function, that is f of x into d by dx of, this is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. So this is the formula that may be applicable. Okay, this is called the product rule and this is called the summation rule. Now, so this is called the quotient rule. Quotient rule. So now the next one is d by dx of, so d by dx of, so f of x by g of x. D by dx of f of x by g of x, that is equal to d by dx of f of x by g of x is equal to, so start from the denominator. Okay, please all of you see this. So g of x minus g of x into d by dx of f of x minus, so f of x into d by dx of g of x by so g of x whole square. Love you catch your point? This is very important problem, important formula only. Okay. Now, so coming to the first problems. Okay, just only simply you have to take so f of x is equal to, find the derivative of these functions. Find the derivative of these functions. Find the derivative of these functions. First one is, so f of x is equal to x square. F of x is equal to x square. So here, so what is the first formula that we have to learn? D by dx of x power n is equal to n into x power n minus 1. Now, so here, please all of you write down this formula. This is d by dx of x power n is equal to, so n into x power n minus 1. N into x power n minus 1. Now, I have to start with this. So differentiate with respect to x on both sides. Differentiate with respect to x on both sides. That means this value is to be d by dx of f of x is equal to, so d by dx of x square. D by dx of x square. How we have to write this d by dx of f of x means? How we have to write? So simply f dash of x dash means that is called the first derivative of the function f of x. Now here we have to apply this formula. Whatever the formula have to learn, d by dx of x power n is equal to n into x power n minus 1. Just you have to put in place of n by 2. That means d by dx of so x square is equal to 2 into x to the power of 2 minus 1. So x to the power of 2 minus 1 means that is 2 into x only. So therefore, whatever the answer you may be getting here, have to write simply in this place. That is the derivative, first derivative of, so the function f of x is equal to x square. Okay. Just only have to follow the basic rules of the derivatives, then automatically the differentiation and the integration concept is very make easy. Okay. Now, so please all of you try yourself. What is the derivative of x cube and so that is x to the power of 4 and x to the power of 5 and x to the power of 6. Please all of you verify this. X cube means, in that similar way you have to do this one. Okay. So then this is, now please all of you verify this, f of x is equal to x cube. differentiate with respect to x on both sides, then d by dx of f of x is equal to d by dx of x cube. Then here I have to apply in this place, please all of you see this, d by dx of, this is the formula, d by dx of x power n is equal to n into x power n minus 1. Here d by dx of x cube is there. Then had to apply the formula in place of n, had to replace n by 3. Then that is 3 into, that is x to the power of 3 minus 1. X to the power of 3 minus 1. Therefore, this is equal to 3 into x square. 3 into x square. So here we have to write in place of this, that is 3x square. This is the first derivative. This is the first derivative. In the similar way, next one. Please all of you do the x power 4 also. X power 4 also, have to do that one. X power 4. So here f of x is equal to x to the power of 4. Differentiate with respect to x on both sides. D by dx of f of x is equal to d by dx of x to the power of 4. Then this is in the form of d by dx of x power n is equal to n into x power n minus 1. Therefore, this is x power, so 4 to the x to the power of 4. Then I have to apply the formula, that is 4 into x power 4 minus 1, that is equal to 4x cube. 4x cube. Now here we have to write, so therefore the derivative of x power 4 is 4x cube. I'll have to catch your point. So likewise, so we have to explain here what is the derivative of this 3x cube is 3x square. Now what is the derivative of x to the power of 4? 4 is equal to, that is 4 into x cube. Just only have to bring this constant into the here. What is the derivative of x power 5? So 5 into, so x to the power of, have to diminish the 1 power of x. Therefore, that is x to the power of 4. Similarly, x power 6 is equal to, so 6 into x to the power of 6 minus 1, that is 5. Likewise, have to practice all those type of the problems. Clarification point. Next one. So the second one is, so d by dx of, so 1 by x square plus 1. D by dx of 1 by x square plus 1. So here 1 by means, what is the formula that may be learned? So that is the quotient rule. So that is d by dx of f of x by g of x is equal to, d by dx of f of x by g of x is equal to, d by dx of f of x by g of x is equal to, so g of x minus, start from the denominator. So g of x into derivative of d by dx of f of x minus, so f of x into d by dx of g of x by g of x whole square. This is the formula. Now, so here f of x is equal to 1 by x square plus 1. 1 by x square plus 1. Now, differentiate with respect to x on both sides. Therefore, this is d by dx of f of x is equal to d by dx of 1 by, so x square plus 1. 1 by x square plus 1. So I have to take it, this one has to be f of x and this one has to be g of x. Then I have to apply this formula, that is equal to, start from the denominator, x square plus 1 into d by dx of the numerator minus 1 into d by dx of the denominator, that is x square plus 1 by, so x square plus 1 whole square. X square plus 1 whole square. Now, so here, what is the formula I have to learn? The first one, what is the derivative? D by dx of k. K means that is the constant. The constant derivative is to be 1. Here, so d by dx of 1 value is to be 0 automatically. Now, so then d by dx of 1 is equal to, this is 1 is to be the constant, the constant derivative is to be 0. In that similar way, d by dx of x square plus 1 had to apply x square as the one function and 1 as the another function. Now, what is the formula I have to learn? That is the summation rule. So, that is d by dx of f of x plus g of x is equal to, here what we did. So, d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. This is called the summation rule. So, for that, I had to take d by dx of x square plus d by dx of 1. d by dx of 1. Now, what is the derivative of d by dx of x square? Then that is the formula of x power n. Already had to explain that one. What is the formula for x power n? N into x power n minus 1. Here x square is there, then 2 into x power 2 minus 1. 2 into x to the power of 2 minus 1. So, plus 1 constant derivative is to be 0. Then automatically this is equal to 2x. Now, here I have to write this one has to be x square plus 1 into 0, because the d by dx of derivative of constant is 0. So, minus of 1 into d by dx of x square plus 1 is, that is 2x by x square plus 1 whole square. Now, this 0 into something value is to be 0. Now, what is the value here getting? That is minus of 2x by, so x square plus 1 whole square. This is the derivative of that given function f of x is equal to 1 by x square plus 1. Left equation point. Now, that the same technique here also I have to apply, that is what is the formula? That may be, so d by dx of 1 by x. So, simple formula, simple technique I have to apply for shortcut method. So, please all of you say this, d by dx of 1 by x. The same problem, so we have to do by using the common sense only. Please all of you say this, d by dx of 1 by x. How do I write? This is d by dx of 1 by x is equal to, that is d by dx of, so x to the power of minus 1. Had to bring that x into the numerator, then automatically it takes x to the power of minus 1. Then here I have to apply the formula, that is minus of 1 into, so x to the power of minus 1 that is equal to minus 1 into x to the power of minus 2. X to the power of minus 2. Then again I have to bring this x power minus 2 into the denominator, that means minus of 1 by x square. Therefore, the derivative of 1 by x is equal to minus of 1 by x square. All of you catch your point. So, now the same technique here also I have to apply in this formula. So, please all of you say this. So, I have to assume, so this is the differentiation with respect to x on both sides. Differentiation with respect to x on both sides. Differentiate with respect to x on both sides. Then automatically, so you may be getting, this is a differentiate with respect to x on both sides. Therefore, d by dx of f of x is equal to, d by dx of f of x is equal to d by dx of 1 by x square plus 1. X square plus 1. So, in this place I have to written as f dash of x is equal to, then, so I have to assume this one has to be x only. The same formula, whatever you have to learn here, that formula is to be applicable to this problem only. Please all of you catch my point. So, this is 1 by x. What the derivative of 1 by x is? Minus of 1 by x square. Here, what I have to treat it as to be, this total term is to be x. This total term is to be x. Then this is in the form of 1 by x. Then have to apply the formula here, minus of 1 by x square. But he has to assume in place of x square plus 1 by x, but whenever you have to write, that one has to be x square plus 1 directly. Okay. Now, this is x square plus 1 whole square. Again, along with into, this is called the internal derivative, then d by dx of the total function, that is x square plus 1. Whatever I have to consider, so again I have to take the derivative of that remaining internal function. Now, this is here I have to apply, what is the derivative of x square? 2x. What the derivative of 1 is? 0. Then this is minus of 1 by so x square plus 1 whole square, so into 2x plus 0. Then that is equal to minus 2x by x square plus 1 whole square. Clarification point. This is the derivative of the given function f of x. Like that, you have to practice all these problems. Next one, the second problem. Third problem is to be, so f of x is equal to sine square x. Again, so here also to apply the formula. The third sum is sine square x. So here f of x is equal to, third sum, f of x is equal to sine square x. Now differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Therefore, d by dx of f of x is equal to d by dx of sine square x. Please all of you observe this, how this derivative is to be, we have to do the problems. So, whenever you have to take this one as to be d by dx of f of x means f dash of x. Then this is in the form of x power n. That means sine square x means, so here this can be written as sine x whole square. Then this is in the form of x power n. I have to assume like that only. Because what is the formula that we have to know? d by dx of x power n is equal to d by dx of x power n is equal to, so n into x power n minus 1. N into x power n minus 1. Now this is equal to, I have to assume this sine square x, sine x as x only. Then that is in the form of x square. What is the derivative of x square? In place of this, d by dx of x square is equal to 2 into x to the power of 2 minus 1, that is equal to 2x. Now sine square x means I have to assume like this as sine x has to be f of x whole square. Then that is in the form of x power n. So that is x square. X square derivative is to be 2x. Therefore 2 into sine x into the sine x derivative, internal derivative, that is d by dx of sine x. d by dx of sine x. So what is the d by dx of sine x? That already I have to learn. So sine x derivative is to be cos x. Therefore this is equal to 2 into sine x into d by dx of sine x means that is cos x. Therefore 2 sine x into cos x means that already have to know the formula in the trigonometry, that is multiple integrals. 2 sine x into cos x is equal to sine 2x. This is the derivative of, so sine square x. Now the next fourth one is x to the power of 4. Fourth one is x to the power of 4. So here f of x is equal to, so x to the power of 4. So that already we have done, that already that is to be over. So x to the power of 4. Then here f of x is equal to x to the power of 4. Differentiate with respect to x on both sides. Therefore this is d by dx of x to the power of 4. Here we have to write in place of d by dx of f of x means f dash of x, that is equal to d by dx of x to the power of 4. Then that is 4 into x to the power of 4 minus 1, that is equal to 4 into x cube. Clarification point. Now, so coming to the next one is e power 2x. e power 2x. How we have to write? That is f of x is equal, fifth one. So f of x is equal to e power 2x. Differentiate with respect to x on both sides. d by dx of f of x is equal to d by dx of e power 2x. What is the formula I have to learn? So that is d by dx of e power ax. e power ax is equal to a into e power ax, that is also already that is to be practiced to you. So then d by dx of in place of a by 2, therefore this is 2 into e power 2x, 2 into e power 2x. Okay, so this is the formula that already had to learn, that is d by dx of e power ax is equal to a into e power ax. This is the formula that you have to learn. Clarification point. Now, so the sixth one is so sine 3x. Sixth one is sine 3x. Sixth one is sine 3x. Sine 3x. Please all of you see this. So here f of x is equal to sine 3x. Differentiate with respect to x on both sides. D by dx of f of x is equal to d by dx of sine 3x. Now this is in the form of sine ax. What the derivative had to learn? D by dx of sine ax is equal to a into cos ax. Therefore, so this is the formula, that is d by dx of so sine ax is equal to so a into cos ax, a into cos x. Therefore this is in place of a by 3, that is equal to cos 3x, cos 3x. Similarly, have to do that one practice as secant square x and cosecant 3x and root of x plus 3. Okay, please all of you see this. So the next one is next example is secant square x. So secant square x. So differentiate with respect to x on both sides. D by dx of f of x is equal to secant square x. Now here, so I had to assume this is secant x as to be so f of x. Secant x has to be so x. I had to assume like this. So then this is in the form of x power n. X power n derivative is n into x power n minus 1. Therefore 2 into secant x, secant to the power of 2 minus 1 of x into the internal derivative into d by dx of secant x. Clarification point. Here had to assume this is in the form of x power n. We had to apply the formula for x power n and also the internal derivative, that is d by dx of secant x. Now this is 2 into secant x into what is the formula for d by dx of secant x? That is secant x into tan x. Secant x into tan x, that is equal to 2 into so secant square x into tan x. 2 into secant square x into tan x. In that similar way, the cosecant 3x and also so root of x plus 3 had to do that one has to be practice. How we have to write root of x plus 3? Root of x plus 3. How we have to write this is f of x. How can you write this? F of x is equal to so x plus 3 whole power 1 by 2 because that is the square root. Then this is in the form of x power n. Apply the formula for n into x power n minus 1 into the internal derivative d by dx of x plus 3. D by dx of x is 1 and d by dx of 3 is 0. Likewise, have to do these two problems has to be practiced. So after that, we'll continue the next problems also. Thank you for kind listening.